What's up, guys? It's Mr. Brengle, and today we're going to be talking about the graphing for the Pendulum Lab that we did. So here I have actually already taken data for the lab, and all I'm going to be doing is going over how to graph the data. So on the first experiment where we looked at how mass affects the period of a pendulum, the two columns that you need to highlight are already highlighted in yellow, or that you need to graph are highlighted in yellow. And so what you're going to do is you're going to click and hold on mass and highlight all the way down to the end of the period column. And then we're just going to hit the insert chart button right here, this thing that looks like a chart. Alternatively, you can also click on the word insert up here at the top and go to chart right there. But I think it's a little bit easier to just hit the chart button, which is off to the side here. So we'll go ahead and do that. And mine has already been set up as a scatter plot, but it is possible that, I don't know where to put this right now. It is possible that this does not say scatter chart here. If you have a different, like if it looks like this, if it's a line, something like that, then you're going to want to make sure that you scroll down below the pie charts and click the scatter chart plot. And then if you end up having like two lines on here, it looks weird, check these three check boxes down here. If the middle one is not checked, or maybe it's the bottom one, it might show up like this. So make sure that both of these are checked down here. It should look like this. Next, I want you to click on customize. So customize, and then we're going to go to your chart and axis titles. If yours does not have a title or labeled axes, then you need to add those. So mine, this is the chart title. I'm actually going to erase the units on the title. We don't need that. I just want this to say average period versus mass, or just period versus mass is fine. And then if you click this drop down right here, you can change this to horizontal axis, and that should be mass in kilograms. And then vertical axis should be average period in seconds, or just period in seconds is fine. Once you have those typed out there and you're good to go on that, you can click off of the chart and axis titles. And the next thing I'll have you do is click on vertical axis. And when we click on vertical axis, I want you to change your maximum value to 5. And what that's going to do is it's just going to zoom out on your graph a little bit in case there was some variance in terms of the numbers. Like if it was bouncing up and down a little bit, the numbers aren't that different. Like if you look at my data here, it's 1.58, 1.57, 1.57, 1.57. So maybe if it was like one of them was 1.59, and then this graph was really zoomed in, it might actually look like it's changing on the graph. But if you zoom out, it's really not, because it's not actually that different. So I just want you to zoom out and create that. I also like to hit this button here, show axis line, which gives us an actual line here on the y-axis. It puts this solid line in instead of it just being the graph there. It kind of doesn't have a line and goes off the screen. So I always click that, and then I'm going to get off of the vertical axis, and the last thing you need to do is go to series and scroll down to the last checkbox, which is Trendline. That's going to bring up some new options. And if you want to add an equation, you change the label to use equation. And that's not really necessary here. This is indicating that we have a small slope, but really this is a flat line. So with the flat line, you really don't need an equation. It's not a big deal, because we know that there's no relationship between the mass and the period. So R squared value should, again, not really be relevant here. So there is your period versus mass graph. And this is what you would enter into your lab report. So go ahead and move on to the changing amplitude graph. This one is going to be very similar, so I'm going to go through this one quickly. I'm going to highlight my data, hit the chart button here, and we can already see, if you're looking at the data over here with me, you can already see that these numbers are staying really constant throughout here. So we should see a very similar graph. So this one has populated a bar chart for me, and I don't want that. So I want to scroll down on the chart under setup and chart type. You're going to scroll down beneath the pie chart, click the scatter plot. It does look a little bit better here, but I have no title. I have no labeled axes. I do want to make sure these two boxes are checked down here. And then I'm going to go to customize chart and axis titles. Let's go ahead and put our full chart title on there. This one should be period versus amplitude. And then we'll go to the horizontal axis, which should be amplitude in degrees. And then our vertical axis title should be period in seconds. And once you have that in, you're good to go on the chart and axis titles. And then I'm going to go down again to my vertical axis. I'm going to scroll down. I'm going to show the axis line. I'm going to make my maximum value 5, so it zooms out a little bit. And then I'm done with the vertical axis. We'll go back to series and scroll down, get a trend line on there. And then again, you don't really need to have an equation on there. You can put one on there if you want, but it is a flat line again, so no big deal on that. So I'll put this in, and then that goes into your lab report as well. And then the last one is changing length. This one is a little bit different. It's not going to be a flat line. So you're going to highlight length of string. I have a lot more data in mine. I did every 5 centimeters, and I think I had you guys do every 10 centimeters in your lab. So that's why mine looks a little bit different, but it is relatively the same. So again, we're going to want a scatter plot here. So I'm going to choose scatter plot. I'm making sure these 2 boxes are checked down here. I'm going to go to customize chart and axis titles. I'm going to edit my title a little bit because I don't want the units in there. I just want to say average period versus length. Or length of string, and just checking. It looks like my horizontal and vertical axis labels are good, so I'm done with that. Don't need to really change anything with your vertical axis in terms of the scaling here. We don't need to zoom out really. I'm going to put that line on there though. You could zoom out maybe to 3 or something like that. Not a big deal. So I'm going to go back to what I had initially, and then the tricky part comes right here. So I'm going to go to series, and I'm going to go ahead and put the trend line on there. And then this is where we need the R-squared value. So you can see here that the R-squared value for a linear trend line. So I have my trend line set up as linear. And when I display the R-squared value, it shows up right here. This is what we're looking at. And it says 0.992. And I've told you before that the R-squared value is an indication of how close this best fit line matches your data. So this is saying that there's a strong correlation between the linear trend line and these data points. As it turns out, this is not supposed to be linear, and it is supposed to be a Groot graph, which kind of takes that shape where it curves and levels off at the top. The reason why you're seeing it like this is because we really need to include even more data than this. It'd be great if we could go from like 10 centimeters up to 100, but we just don't have time to do that in class, and it's hard to do that with the pendulum stands or the ring stands. Don't give us enough height. We'd have to go off the side of the desk or something like that. So my point here is that if you change the chart or the trend line type to polynomial, you'll notice that it now has switched the R-squared value to 0.99. So the polynomial trend line is for curved graphs. And since this is supposed to be a curved graph, you can actually see that fits those data points perfectly. So if I go back to the linear one, you will notice that it's kind of like it's below these dots. Get my pointer back. So like these dots aren't exactly on the line. This one's below it. This one's above it. Couple of them that are right on it. This one's below it. But again, if I switch back to the polynomial trend line, these dots are pretty much right on that line. So it gives us a 0.999 R-squared value, and that's indicating that this fits perfectly, basically, with our data points. So it is supposed to be polynomial. It is supposed to be a Groot graph, the square root function graph. So this is what we want, except that when we get a curved graph, we need to linearize the data. So the way to linearize your data with a square root function graph or a Groot graph is by plotting y squared versus x. So what that means is length of string over here. This is our x-axis. So what I'm going to do over here is I'm going to copy all of those values in here because we're not changing the x-axis. It's y squared versus x. X stays the same. So I'm just going to put in equals, and I'm going to click on my first data point there, and I'm just going to put that in and drag that down. So the point here is that your x-axis, the length of string, should be identical to what you have over in this green column here. Now, what has to change is what's on our y-axis. We need to square these values that are on our y-axis. So we need to, instead of graphing average period, we are now graphing average period squared, and then the units would be seconds squared. So to do that, we're going to enter an equation. We're going to hit equals. I'm going to click on the first average period, and then I'm going to enter the caret shift 6 and a 2. This is going to square that value right there. And I'm going to hit enter, and then I'm going to drag this down and fill all these in. So now you can look back and forth between these numbers, and they are not the same anymore. We've squared all of them. And so what this is going to do is when I graph this data, it is going to straighten that line out perfectly, hopefully. And it does look like it's done a pretty good job here. So we've got the scatter plot. We've got these two boxes checked down here. I'm going to go to customize. I'm going to go to my chart and access titles. And I am actually going to change my title because I don't want the units in it. I just wanted to say average period squared versus length of string. So I'll do that. And then my horizontal axis should be length of string in meters. My vertical axis should be average period squared in seconds squared for the units. Once you've got that, you can go ahead and go on to series, and we can put a trend line in. When we have a linear relationship like this, we definitely want to put an equation in on that. And if I show the r squared value there, you can see the r squared is 0.999. So that's good. That means it fits perfectly. And at this point, you're done. Don't need to do anything else. You've got your second graph. It's linear, and this can go into your lab report. So that concludes the graphing of the Pendulum Lab. So you got basically 4 graphs there, one for mass and period, one for amplitude and period, and 2 graphs for string or length of string and period, because there was a relationship with these two variables that was not linear, so we had to linearize the graph. The other two, we did not need to change these because there's no relationship with these variables. When you change the amplitude, nothing happens to the period, so we don't need to do anything with this. It's already linear. Can't make that any more linear. So that'll do it here. Make sure to let me know if you have any questions, and then also watch the video that I've made going over the lab report for this lab, and make sure that you've got all of that straight away. Okay. All right. Have a good